All right, so 1.3, sample data, collecting sample data. So the first thing I want to talk about is what's a simple random sample, so I'll throw up a definition up there. So it says a simple random sample of n objects is selected in such a way that every possible sample of size n has the same chance of being chosen. A simple random sample is often called a random sample, but strictly speaking, a random sample is a little weaker requirement. So we're not really going to make the distinction in this class, so we'll kind of talk about it. So ideas of a simple random sample is something like this. Like, this would not be considered a simple random sample if, let's make sure that you understand. So let's kind of look at this picture right here and just disregard the words up here. So let's say I flip a coin. I flip just one coin. I want to get a sample of 3 from these 6 people, but I'm only going to flip one coin. If I flip heads, I'm going to get the girls. If I flip tails, I'm going to get the boys. Now, in that situation, that would not be a simple random sample because remember that for a simple random sample to happen, it says every sample of size 3 must be possible. So I should be able to get, 2 girls and a boy, or 2 boys and a girl, or even 3 girls, or even 3 boys, and so on. So I should be able to get every possible sample of size 3. But since I'm only flipping a coin and heads is all girls and tails is all boys, that means I'm either going to get only girls or only boys. So a simple random sample would be 3 coins, flipping 3 coins. So if I get heads, I get 1 girl. If I get tails, I get 1 boy. So if I flip 3 coins, I do have the possibility of still getting 3 girls in a row, but I also have the possibility of getting 2 girls and a boy, or 1 girl and 2 boys, and so on, or even all 3 boys. So that's what I recommend. That's what I mean by a simple random sample. Now, other sampling methods is a random sample is each member of the population has an equal chance of being selected. So we're not really making a distinction between these two in this particular class. So a lot of times they'll say a simple random sample. So something that is just random might be like computer generated. Like when you get robocall, that's technically supposed to be a random sample. Systematic sampling is like if I wanted to sample, say, 1/3 of my class. What I could do is I could sit you guys all up against a wall, and I could take every third of you. So every third person, I could take that. And since you guys are walking up against the wall somewhat randomly, this systematic version is actually going to work. Or, if you want to take course sample, like if you want to see if your road that we've built is good, what you could do is you could take core samples, say every mile or every 2 miles or every 3 miles and so on. You can systematically sample the road. Now, convenience sampling is not good sampling. Like, this is funny. Hey, do you want to, we're not gonna argue about this. It's too darn political. But asking somebody a question from an apartment, the reason why this convenience sample is not a good sample is because he could choose to answer or choose not to answer. So really, this convenience sample is a special type of a voluntary response sample. Also, if you're doing a convenience sample, if you're just asking from a particular location, so if I just have one person like in downtown Port Huron asking, sampling people, the data that they get is probably not going to be good because it's voluntary response, but also it's not going to be representative of, say, in our entire country, if that's what you're actually trying to do. But if you're trying to get data just representative of just Port Huron, it's still not going to be good because you have voluntary response. Stratified sampling is done by separating groups into 2 strata. So maybe we'll have Democrats over here and Republicans over here. And then what we're going to do is we're going to randomly select people from each strata. So this is a strata, this is a strata. Like you could also have all males and all females, and those would be considered strata as well. So what we do is strata are groups of people that share some commonality. So you might wonder why there's 3 over here and there's 4 over here being selected. Well, the reason why is because the sample is supposed to be random, so it is possible that you get 3 here and 4 here, or maybe 4 here and 3 here, or even maybe 5 here and 2 here. But if it is random, as it's supposed to be, these numbers should be really, really close to even. They should be very, very, very close. Something that looks very similar, but it's not exactly the same thing, is stratified sampling. What you do is you separate it into strata, and then you randomly select some from each group. So just some from each group. Now, cluster sampling, what you do is you set them in clusters, and of course these clusters also tend to have commonalities. So, for instance, if I want to sample our college, what I could do is people have already been clustered into their class. But But instead of just grabbing some from each cluster, what we do is we take the entire cluster and sample everybody in that cluster. So instead of just taking some from a group, we take all from this particular group, and all from this particular group, and maybe all from another particular group. And as long as this selection is done randomly, this is actually good data. So the idea is, what's good data? Random is good data. Systematic is good data. Systematic is not good data because it's voluntary response. Stratified sampling is good data. Cluster sampling is good data because these represent still a randomness in there. They still represent essentially a simple random sample, And the rest of it, I'm gonna have you guys read. Those are the main focuses of that particular.